to do the regular helper video, this time for assignment 3, this one on finite state machines. You'll note that I don't have any pseudocode pulled up. That's because there's basically no pseudocode for this assignment. If you really, really want sort of a pseudocode-ish things, the closest you're going to get is this sort of blog post. But really, just following the steps here is key. So let's go ahead and open up assignment 3. This is the version of it that you last saw in class when we first covered FSMs. As a reminder of the breakdown here, you're going to want to implement Pinky and Clyde, and then create your own custom ghost. Those are sort of the 3 high-level tasks for this assignment. The implementation of Pinky and Clyde should be a lot easier. The implementation of your own custom ghost, a bit more challenging. So let's go ahead and remind ourselves what this looks like. If we just go this is now currently with the mouse click agent. As a reminder, you are not going to be tested with the mouse click agent or the keyboard press agent, which is another one that allows you to control it, as I'm clicking and controlling it right now, because you're going to get weird behaviors with those. So right now this is set up as Blinky, and that was the mouse click agent. As a reminder, if I delete mouse click agent and I look over here where it says Pac-Man agents, I can click and drag one of these, like Greedy Agent, for example, into the scene. And instead of me controlling things, this Greedy Agent will control things. The first thing that we're going to want to do is implement Pinky. So to do that, we're first of all going to need to replace Blinky right here with Pinky, just like that. And now Pinky is going to spawn in. If I go ahead and run it, and wait a few seconds, we see a pink ghost show up. It's momentarily red, but it's not actually acting like Pinky. So let's see what's going on here. So this Pinky object that I just added to that scene, if I open the prefab, you do not have to do this. This is just for your own reference point. It's using this Pinky script. So this Pinky script, if we look at it, is extremely simple. It's extremely straightforward. We have a start state where we initialize this. And then we have a setup of our current state, which is just the Pinky state, and then we enter it. And that's literally all. That's literally all there is to it. You can ignore this comment. This comment is for me. If you want, you can remove this. Actually, let's see. I think it'll still work even if we remove that. Let's double check. Thinking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, never mind. So it does actually need to be initialized. You cannot remove it. Yeah, this line was just for me. So don't go about removing that. But all of the logic, right, because this is an FSM, is stored in individual states. In this case, this one state handles the main behavior of Pinky. Let's go ahead and take a look at it. I'll actually go ahead and I'll double click in this case instead of just opening it in Sublime Text. Even though Mono Behavior Visual Studio takes a while to load. Yeah. You can do it. All right, there we go. So this is the initial setup for this Pinky state. Now, if you've taken a look at the other states that you were given, as a reminder, you're given Chase, Eyes, Frightened, Scatter, and Whimsical. These are fully implemented states that you're given. If we take a look at Chase, we can see that, in fact, these 2 scripts are functionally exactly the same. It's because all I did was I copy and pasted the Chase state into here, and then I changed some names, and I changed the name of the state that it's being tracked. So that means that this is just using Blinky, the Chase state's behavior. The connection here is that if we go to blinky.cs, right, we can see that initializes Chase state. So it's just using Blinky's behavior instead of Pinky's intended behavior. So let's take a look here. What are the differences? Oh, geez, what's going on? No, I don't want to restart the updates. Okay. Cool. If we take a look right here, we can see that we have a few things for Pinky, always in bold, or at least in most cases in bold. So by default, they need to follow the rules in terms of when they should enter scatter and frighten state. But just by copying and pasting the chase state, we've got that already, right? We can double check this right over here. There we go. We can see when we just enter it, we're setting a 20-second timer. And then after those 20 seconds, we are going to scatter state. So we're going to scatter state at the right time, though there's an issue with the location. And if we've just eaten a power pellet, then we go to frighten state. And frighten state is already handling the transition to I state. So all of those things are already being handled for us. We don't need to worry about that line. But we do need to have Pinky target the grid cell closest to 4 grid cells in front of Pac-Man. Versus if we take a look at what's happening now, right, Pinky is targeting just Pac-Man's location. And then if we go back over here, Pinky's scatter position should be the top left corner. So that's it. We just need to make basically 2 changes to the script. One is to change the place we're targeting, and another is to change the scatter position. In terms of how we do this, because you might be saying like, oh, what does it mean in 2 cells in front of Pac-Man? Well, I'll remind you, oh, geez, I keep on clicking wrong things. I'll remind you that a thing we can do is reference, oh, hello, Pac-Man info dot instance dot facing. This object, if we go to it, or this variable, is a vector 3, and it gives us just a vector 3 pointing in the direction that Pac-Man's facing. But we can't just do this, for example, though that's getting us closer to what we want, because this is just going to add, a left vector 1, 0, 0 if it's facing left, a right vector minus, that would be minus 1, 0, 0 for left, plus 1, 0, 0 for right, etc. Here we can go ahead and just show what this is, right? Yeah, so it's just doing vector 3 dot up, vector 3 dot down, vector 3 dot right, or vector 3 dot left. So that's all it's doing here. This also, by the way, is why you can't just use the mouse click or the arrow keys agent, because it will just default to going to the left if Pac-Man isn't moving. So this is just going to add 1, like 1.0 to some dimension, either in the positive or negative sort of axes. But that's not our goal, right? Our goal is to target the grid cell closest to 4 grid cells in front of Pac-Man. So we need this to reference the position 4 grid cells in front of Pac-Man, not 1 value in front of Pac-Man. I'll leave the rest of this up to you, but I'll note that what we can do is, for example, multiply this by, obstacle handler dot instance grid size. Just for example, as a thing you could think about. The last part of this right here, the closest grid cell, or the grid cell closest, that's handled automatically for you in set target. If we jump to set target, we can see that we're already going to grab the closest graph node position to whatever position we're given. So we don't need to worry about calculating the closest. That's done for us automatically. So literally, you would just need to make a change here, and Pinky would be done. So we can use the same notion, the same concept here in terms of setting up poor old Clyde. If we open up Clyde right now, right, we can see that right now Clyde is just using chase state, but we need Clyde to have his own state. So let's go ahead and do that. Clyde state. And let's double click here. Clyde state. We can just literally take our Pinky state. They told you not to copy and paste, I'm sure, in your CS classes. But it's totally chill. Don't listen to them. We just need to make changes here to the names and to the name of the state. Make sure to give each one of the states you create, like this was just me creating a state, make sure to give each of them a distinct name here. And then back over in Clyde, right, we can just go ahead and change that to that. Now, I'm not going to give you as much direction in terms of the Clyde changes, but I'll note you again will have to change the scatter position. You're also going to have to change to reflect this behavior for that set target. But that's all the easy part of the assignment. This is all relatively straightforward. The difficult bit is custom ghost. So for custom ghost, rather than just doing that one time, creating one new state, you'll instead need to create 3 new states, at least 3 new states, and making sure they're not replicating the behavior of any other states. Now, I mentioned down below in the grading or marking section how I'm going to be calculating this. It's basically I'm going to look at if I run the 2 states simultaneously on like a virtual ghost, do they show different positions over time? So it doesn't matter if they're visually distinct. They really have to be mechanically distinct. That's what we mean here. No replicating behavior. I'm not going to give you anything else on this in terms of how to do this, but I'll note, right, that if you're going to have these 3 new and unique states, you need to make sure that you're transitioning between states. And you can already see examples of transitioning between states here. You also need to make sure that all of your states show up, which you can do pretty easily, right? You can just have a debug line in update or even just in enter if you don't want to have just a whole bunch of debug lines. But in each one of your enter states, you could have a distinct debug log to say, hey, I just entered this state. In terms of ideas for like distinct states, what I'll suggest is you have access to a whole bunch of extra things. Where did I talk about that? It might be in the hints section. I think it's in the hints section. Let's go down to the hints section. No, wasn't there. Where do I talk about that? Score handler? There we go. So you have access to agent constants, pellet handler, ghost manager, obstacle handler, Pac-Man info, and score handler. There's also a whole bunch of other things, right, that you have access to. And you can use any of those to come up with potentially unique states based on unique conditions, which would count as unique behavior, right? Because it would, if I run it for long enough, we'll see a change in the behavior. Also notably, you have access to all the functions in FSM agent because Clyde and Custom Ghost and Blinky are all FSM agents. And in fact, when we look inside each state's update function, you see it past that agent, the agent that is going to be running that state. So if we want to do things like, change the speed, these are things we can do. We can also check if we're close enough to things, set targets to things, set timers to things, get our position, etc. All of these things together can be used to do these things, to create these 3 new states. What I'd recommend doing is first thinking about 3 new states and then working to implement them. That's sort of the steps that I would take here. If you need further help, I would recommend asking me questions individually. Because again, this is the sort of meat of the assignment, so I'm not going to give you further details here. Okay, one last thing that I wanted to do is just go over the grading, marking, and the hints section again, just to make sure that students actually do that. Also talk about the extra credit a little bit. So in terms of grading here, right, the homework assignment is worth 10 points as per the usual. You're going to get 2 points for Pinky and 2 points for Clyde. That means that based on what I just did, you could just make 2 changes to 2 lines. Well, not exactly for Clyde. It's a little bit more than that. But you're going to just basically do that. And then you can get 4 out of 10 points just from that really easily. That part should take you no time at all. Oh, real quick, while I have you here, I will say that if you're looking at calculating distance between 2 positions, there's a really easy way to do it, which is just say, what if we did like Pac-Man location minus, I don't know, vector 3.0, just as an example here, and then just did magnitude. And you could put any other vector 3 in this position. Just a thing to think about. Just a thing to think about. Anyway. Then you get 1 new point, or 1 point, for the custom ghost showing at least 3 new states during testing. Again, make sure that you give each new state a distinct name. That's because for the auto grader, right, I have to be able to basically cache or hash rather each state based on that name. So that's why it's important that it be unique. This is very important. You don't get points if you're not going to get this 1 point if you had the same state name but 3 different behaviors for 3 different states. Again, this is the way that I'm going to be checking this. As I mentioned earlier, running the 2 states in parallel, or the X states in parallel. Then finally, you get your last 5 points. So 50% is for your custom ghost outperforming the 3 given AI Pac-Man agents with 2 withheld agents. Outperforming here means that your custom ghost has to eat these agents faster than the existing ghosts, which really just means Blinky, because Blinky will beat any of the other ghosts. Then finally, there's the extra credit here. So there's two parts to this extra credit. The first is that in addition to your 3 new states, your custom ghost must make use of standard, scattered, frightened, and eyes states at the appropriate times. This means that if you just want to go for the basic 5 points, you don't have to use scattered, frightened, or eyes states, which means that you can completely ignore when Pac-Man eats the power pellet. And let me tell you, that'll do a lot of good in terms of ensuring that you outperform Blinky. So that makes that significantly easier. But it's not guaranteed still. So you still have to think of some good states. And they have to still be unique. The second part of this is that your ghost must be harder to deal with for simpler AI agents and easier to deal with for more complex AI agents. So basically, you can't just have an agent that destroys Pac-Man as quickly as possible. You want to have an agent that is harder for the worse agents and it's easier for the more intelligent agents. Basically, what I'm looking at is the AI Pac-Man agents having this score breakdown. By score, I mean the total number of pellets that they get before they die, which you can see just on the top right of your screen. So random versus greedy coward versus withheld agents versus withheld agent 2 score. So it should follow this sort of breakdown, though notably greedy coward and greedy might be a little bit closer than that. I think that actually I've changed that in the version that you have, so it's less than or equal to. Just to give you a brief sense of that, right? Let's go ahead and get rid of greedy and replace you with random. And let's go ahead and get rid of pinky and replace you with blinky. So random's going to vary a lot, but just on average, right? Ooh, hello. There we go. I don't know how random got caught there. Oh, there we go. So I didn't even catch the number of pellets. Okay, so you're at 10 pellets right now, 12, 13, 14, 15. Let's see how quickly you die. Okay, so there's around 20 pellets that random died. In comparison, if we look at greedy will be pretty much deterministic. Not exactly deterministic, but close. Sorry, greedy. So if greedy against Blinky, let this run. Here comes Blinky. Blinky is gonna potentially could have gotten taken out there, which would have made this a little bit slower. Ooh, still might happen. No, just barely avoided it. And 104. So 20 versus 104. So very easily, right? Blinky is already doing this, no problem. But Blinky is also a fairly balanced ghost, all things considered. Keep losing where I am. Then let's look at greedy coward. So greedy coward won't get in that situation where it doesn't eat the ghost and also stays close to the ghost, which is why Pac-Man died so quickly that time. Let's go ahead and have greedy coward run. So greedy coward is going to try to get pellets, but also is going to try to avoid the ghost. And that means that it's going to go way to the other side. Woo, you got this. You got this. It's so hard to be greedy coward. It can get into this funny thing. So it's going to try to run away, right? Here you go. There you go, greedy coward. Get all them pellets. Oh no, it's going to get caught in the corner. Ah! So you can see it got about 90, so which is why I was saying that it's less than or about equal to between these two. That's an understandable thing if it doesn't happen. But that's the general sort of breakdown that you're looking for here. I'll tell you, withheld agent 1 is significantly better than greedy coward. Again, there's some randomness between here and here. And withheld agents 2 is significantly better than agent 1. So as long as you have these 3 in roughly this ordering, with this notion that this is going to be a little bit vague, you should be good for these withheld ones, as long as you're not doing some extremely simple thing. I'll also note there are ways that you can actually pay attention to the score and have behaviors based on that in order to ensure you have this happening. Hints, I already gave you this one. Don't have your ghost teleport. You can change the base speed through 2 functions, but that's it. You can use debug logs, and finally you can access the time scale to make things a little bit faster if you're finding it being troublesome for particular things. Okay, that should be it. If you have any other questions, comments, or concerns, hit me up on the Discord or email, and otherwise, best of luck with this assignment.